Well, hello everyone. Thank you so much for joining PRKN's Water Wednesday webinar. We'll give it about one more minute just to let people come in. But today's topic is all going to be about freshwater mussels. So I'll give a brief presentation just about some basic freshwater mussel facts and about the 50 million mussel program. And then we're going to move into a conversation with Dr. Jess Jones, who we're so happy has been able to join us today. So, Dr. Jones, thank you again. Really appreciate it.
Of course, Evan. Yeah, happy to join.
Great. Um, if anyone has any questions kind of throughout the webinar presentation, please feel free to use the Q&A form. You can find that at the option More. Click that, and the Q&A form button should follow right there. And after Dr. Jones and I's conversation, I think we're both happy to answer any questions that anyone will have. So I'll give it about 30 more seconds, and then we'll go right into it. So thanks, everybody. Great. All right. Well, with that, then, I'm going to go for it. So thank you, everybody. Today's topic is going to be all about freshwater mussels, a little bit about the wonderful creatures that they are and our program with them and the incredibly vital role that they play in our rivers. So a little bit about particularly like this type of freshwater mussel. Um, the uni onitas are known as the pearls of, I call them of the Potomac, but truly the pearls of any river or freshwater system. Um, and they typically reside in rivers, streams, lakes, particularly places that have sandy or gravel substrates. These are quite old bivalves. They've been known to originate since the Jurassic period originally in East and Southeast Asia. But since then, they have been distributed worldwide, particularly now in North America, where they've been known to have some of the greatest diversity, particularly in the East Coast, east of the Appalachian Mountains. We're really lucky to live in a region that has such a wide diversity of freshwater mussels. And so what makes these freshwater mussels really unique is particularly their life cycle. So these types of mussels, unlike other mussels where they have the types of fibers that helps them hold onto the different substrates, these mussels have a foot, very much like clams. And the other thing that makes them really unique is their particular lifestyle. So if you can see the image here, we'll start at the bottom where you have a male and female mussel. And the way that they reproduce is the male mussel usually needs to release sperm into the river system, and the female mussels need to be downstream of the male mussels. So then they take in the sperm, and once they have to fertilize eggs, they need to share them with host fish. And so these fertilized eggs, known as glaucidia, need to get shared with the fish as a better way to distribute the mussels across the riverbed, and the fish also gives them a bit of protection as well. Um, Now, if you're looking to go into a really amazing and fascinating rabbit hole about the ways that these mussels share their glaucidia, I highly recommend looking into it because they're all very fascinating. And they do it through several different ways. Um, One of the first ways is they have different lures. Um, all of the images here are of different lures that freshwater mussels have attached to their bodies to mimic fish or to mimic crayfish or worms or things like that. Particularly picture B, I mean, to me, that truly looks like a fish, but it helps lure a lot of the host fish to the mussels. And when they get close enough, the mussels then release a lot of their glaucidia, which either lay on the fish or actually go through the fish. And if you can see here, the glaucidia attaches to the fish gills. So the glaucidia will stay there and actually kind of become part of the fish skin and the fish gill skin from anywhere from 1 to 3 to 4 months until they are mature enough to have built their shell, and then they will pop off. And they will move into that final stage where there are juvenile mussels, and they will sink or burrow into the substrate where they can grow and lead to maturity, beginning the cycle again. But lures are not the only way that these freshwater mussels attract host fish. They can do it as well through things like conglutinates, which are packages of fertilized eggs or glaucidia. Um, and as you can see, they look like little worms. So another way to attract the host fish to the mussel, and they can either consume or the conglutinates can get attached to the fish themselves. Once that happens, of course, the glaucidia release and the cycle begins again. And probably the most dynamic way that this happens is by literally snapping shut. This happens with the snuff box mussel. But when the host fish gets close enough, the mussel actually snaps onto the fish. And what you're seeing here is just the edges of the shell itself, and it holds the fish in place as it releases the glaucidia. Um, so if you're looking for a rabbit hole, I really recommend this. It's very fascinating. If anyone knows the YouTube series True Facts About Animals, they have a really informative and funny video about all of this. So I highly recommend that. Particularly in the Potomac, we are lucky to have about 21 species of freshwater mussels in the Potomac. Some of the most common species that you'll see I have listed here are Eastern elliptio, Eastern lamp mussel, pond mussel, and floaters. Um, and the map on the right that you'll be able to see here is both a current and historical map of the spread of Eastern elliptio. And this is just in Maryland, but Maryland and DNR did surveys based on both historical data pre-1990 and current data of where these mussels reside. And you can see, if you can follow the trace of the Potomac River, which is on the southern edge of the Maryland map, you can see where all of the green dots, those are the current places of the Complanata, that they are truly hugging right along the shores of the Potomac. Then when we get into the DC area, you've got a better mix of both historical, which are the black bullseyes, and the green dots. And then once you go into the southern lower Potomac, that's where the water really transitions to pure freshwater to more brackish and more salty water. And so you can see that now the mussels aren't really along the edge of the Potomac, they're further up into the tributaries because they want to be in that fresher water. Um, and so we're really lucky and thankful that MDNR and various state agencies do this type of work so that we can better understand what our mussel populations are looking like in our rivers. And historically, freshwater mussels, of course, are very important for the environment and the ecosystem, but they've also served as a really important cultural uh, point because they've been used for food, they've been used for tools, and of course, they've been used for both spiritual purposes and used for jewelry making as well. So they're quite the multi-talented bivalve of the Potomac River. But including all of that, they're quite mighty because of their environmental services. The three that I like to highlight here is particularly with Potomac Riverkeepers Network's work, because we're concerned about water quality and water quality safety, mussels are really powerful in that freshwater mussels can filter anywhere from about 8 to 15 gallons of water a day. And of course, that depends on maturity level, species, a host of environmental factors. But in that, the water that they're filtering out, they can pull out a lot of the excessive nutrients or pollution issues that might be in the water, which is great for regulating excessive nutrients, toxic chemicals. And there's even studies done to show that freshwater mussels can actually filter out microplastics. So incredibly powerful as a water quality improvement tool as well. And along with that, of course, mussels are really great for habitat building because they burrow down into the sediments and into the sand and gravel. They actually help building these mussel beds and these habitats that other animals can build off of and find protection from. So mussels serve a host of different roles, and they're incredibly powerful for the environment. And this is just a little bit of a clearer message and chart of that. So as you can see on the left, a lot of the mussel actions are great for filtering and the excretion and the biodeposition. So not only what they're filtering through the water, but what they're depositing in the substrate is good for supporting nutrient cycling, actually supporting the habitat, and supporting the overall food web itself. And the mussels themselves, their tissues and their shells are also great for supporting habitat building. And like I said before, it's great for these more cultural aspects like tools or spiritual or apparel enhancement. And so because of all of that amazingness, PRKN in 2019 embarked on a mission to build out and restore a lot of the freshwater mussel populations in the Potomac River. And so in 2019, we created the 50 million mussel program. It initially began with an education station and baskets, which is the top right photo here. But as we've quickly then expanded into working mussels into various lawsuits and mitigation proposals, and we've been expanding our restoration work as well with our wonderful key partners. You can see that this is built not only just out into a restoration program, but a community program as well. You can see that on the bottom right photo, where we're working with volunteers on a mussel tagging and a mussel measuring event. So this program from 2019 has really started to expand and expand rapidly. And one of the ways that it has done that is through the newly constructed science barge and floating mussel docks. So the picture on the left-hand side here, you'll see is our first meeting of when the floating docks and the science barge were officially built. The larger structure itself is the science barge that is hopefully going to be used for community science initiatives in the future. And the lower section here are these floating mussel docks. And we're really hoping that this allows a space for freshwater mussel propagation to expand and live in the river itself, and provide space for our various partners that these mussels can grow in the river and be introduced to the natural environment and hopefully grow even faster. So the photo on the right-hand side you'll see is our current place at that right now. You'll again see the science barge, the floating mussel docks, a second mussel floating dock that was repurposed from growing oysters, and the boat on the side there is the Sea Dog, where we hold our community water quality science program. So this is now docked at National Harbor. I invite you all to come visit, and we would love to show you the Sea Dog, show you around, and we're really excited for the potential that this has. And that potential really began on June 16th, where Dr. Jones' lab brought the first 1,200 mussels to the floating docks. And so you can see us there. We're working to install the mussels. And since then, they're doing quite fine. Actually, it's almost been a month, and they're already growing quite a lot. So it's really just amazing to see this growth happen in real time. Um, And truthfully, like this program could not happen without several partners with this program, particularly our key ones, which are Maryland Department of Natural Resources, Virginia Tech, and National Harbor. And so because of that, I think we're really fortunate that we get to speak with one of our very key partners who has been here since the beginning, Dr. Jess Jones. So Dr. Jones is a restoration service biologist with the U.S. Fish and Wildlife Service. He's also the co-director of the Freshwater Mollusk Conservation Center. And Dr. Jones has really been with the 50 Million Mussels Project since the beginning. So I'm really excited to be chatting with you today and would love to step into this conversation. Yeah.
Yeah. Well, great. Thanks, Evan, for having me.
Yeah. I just wanted to start as well. I'm just personally curious too of well, a little bit about how you got into freshwater mussel conservation research, um, and what initially drew you to these creatures. Yeah.
I would say I kind of fell into it. I mean, growing up as a kid, I did a lot of stuff outside. Did a lot of fishing, and I was always drawn to being on streams and ponds, and being in and out of around water. But I didn't know what to do with that. I didn't know how you could translate that into like a career or anything. So I like a lot of kids, growing up in the 80s and 90s. I mean, we just had jobs and we did whatever we could to make money. I, did a lot of, like construction jobs and landscaping jobs, worked in different restaurant businesses and things like that. And, I came down to Virginia Tech studying different things, but I didn't even really know that you could study fish and wildlife, sciences and conservation. I didn't even really know that that was an option. And it wasn't probably until maybe my early to mid 20s that I started to become aware that you could go this direction as a career. And I was fortunate enough to meet up with a professor at Virginia Tech that was studying mussels at the time,
Mm,
and he was he was a pioneer in this field. His name was Dick Neves. But So I started working with him, and his team, and I learned quickly that you could snorkel around in streams and collect mussels, and do something that was pretty interesting. And the more I did hands-on observation with them, I was like, wow, this is a really interesting group of animals.
mm,
And so I just kind of fell into it and realized that you could make this into a career, that you could get paid to do this kind of work. And growing up, back then, you just it was harder to kind of bump into things. And so I feel fortunate to have, bumped into this. And then I just connected with it right off the bat because I just had this natural affinity to being on rivers and streams. But I didn't even know, it's like I spent all this time, tromping around rivers and, fishing and everything. But I didn't even know right underneath my feet was this fauna. I didn't even know that they existed, right? And so, I mean, I knew about oysters and some of the marine bivalves, but I did not know at all about freshwater mussels until I started, working, in this field as a technician in, like my early 20s or so.
yeah. I'm kind of shocked that that mussels, and especially freshwater mussels, have not gotten the publicity or the popularity that they deserve. Because they're right in our rivers. I mean, right? Like they're right in our backyards. Yeah.
Well, you think about the different ways that people interact with rivers, fishing, for example. They might swim or they might, kayak or canoe, and you really would have to be kind of looking for them, to know that they were there. And a lot of people would be going down a river, maybe in a boat or something, but they're not, looking down the bottom where these guys live. And
Hmm.
so that's kind of the challenge is, knowing that there's this, really diverse bottom fauna in rivers that harbors and holds the fish. It also has the crayfish and the snails, the freshwater mussels, and then, hundreds of species of aquatic insects. So the overall assemblage or fauna in the bottom of rivers throughout the Appalachia, but throughout the country, throughout the world is pretty immense, actually.
I would love to go on one of these, one of the surveys that they do. Because you're right. Whenever I swim or kayak, I really don't see the mussels, but they're constantly working. Yeah.
Mm-hmm.
I wonder if you'd be able to give us a little bit more insight into the ecosystem services that freshwater mussels give. I kind of briefly mentioned like the water
Well,
quality, but yeah.
I think that people can connect, with, like the photos that you showed, right? The one tank has got mussels in it, and the other tank does not have mussels in it. You stir up and make the water cloudy, and over time, the mussels clear out, the cloudiness or the particles that are suspended in the water. I would point out a couple of things, though. Interestingly, like if you were to let the tank that didn't have the mussels to stay there over time, it would kind of clear a little bit, right, over time. But then there would be this, kind of fine cloudiness to the water. And the reason for that is that there's the larger particles that settle relatively quickly, okay? And but then the really fine stuff, the stuff that might be, just really small, 1, 2, 3, 4, 5 microns. And so you're talking just to something way smaller than a millimeter, something really super small. That stuff can stay in suspension for a long time. So, like if you look at a pond or you look at a lake or something, there's phytoplankton out there. There's a lot, but there's also small particles that are just floating around, and mussels can specifically clear those really fine particles. So
Mhm.
they actually specialize in particles that are like 1, 2, up to maybe 10 microns in size. So something very small. Okay. And so what they can do in terms of clarifying the water is, it's really quite extraordinary that they could, capture something that small and then actually feed on it. And if you think about other examples, people have read about, when, the Chesapeake Bay was filled with oysters when, say, Captain John Smith and others came into the Chesapeake Bay in the early 1600s. Well, they could see all the way down to the bottom, 20, 30 feet down to the bottom. It was that clear back then. But of course, there was substantial, oyster beds by the, billions, I'm sure, not just millions, but billions of oysters throughout the bay. So their collective action of filtering could really clarify the water. And so, as hard as that is to imagine, we have real-time examples of bivalves in action doing exactly those kinds of things. So, if you look at the Great Lakes, for example, Lake Erie and some of the other lakes up there, but say Lake Erie, for example, zebra mussels have gotten in there. They've invaded that system, and then quagga mussels have invaded that system. And so they've reached really high densities, billions of animals out there. And so 30, 40 years ago, you couldn't see the bottom, in Lake Erie. But now, there's so many mussels out that they're clarifying the water where you can see it. And now, is that a good thing or a bad thing? I can't really say. But we can say that their capacity for clearing water can be very substantial when the numbers are high. We know that. And so there's no doubt that freshwater mussels can have a very significant effect at high densities on the amount of particles that are out there in the water, whether those particles are phytoplankton or fine particulate organic matter or whatever it may be. We've all seen rivers in cloudy conditions or muddy conditions, and then over time they clear, and part of that clearing is just material settling out, but also the biota, things like freshwater mussels, filtering that water.
Mhm. A lot of, I guess I've always, uh, I've been curious about this of the particles that the mussels are filtering out when they kind of pass through the mussel. Are a lot of those particles held within the mussel, or is it then like secreted into the sediment itself? I guess like how do the particles
So
like leave the mussel?
they do two main things. The other thing that's interesting about both marine bivalves and freshwater bivalves is that they can be very selective in both what they clear and then what they ingest. So
Mm,
they can clear, they can collect, clear, filter, particles that they want. So let's say that there's I don't know, a particular algae bloom out there that's a very nutritious algae that they really like. Both marine bivalves and freshwater mussels can filter and begin to focus on that particular algae species. Now they may, in that process, um, filter in things that they don't want to eat. And so they can bind that up into a pseudo feces and eject that for and not ingest it, not bring it into their stomach. Okay, so they
mm,
can they can do particle sorting. They can filter in the material and then sort them, eat what they want to eat, and then ingest or package up into pseudo feces material that they don't want. Now, they might not like it, okay, but that mucus, ingested material will go into the substrate, all right, and then bacteria can begin to work on that, so it can bump up the bacteria in the stream bottom, and then other things can feed on that. So they do what's called they're like basically coupling the suspended material in the water, whether that's in like a bay or a river. They're filtering out that suspended material, bringing it down into their bodies, and then ingesting it into the stream bottom. So
Hmm.
they're bringing the stuff that's in the water down into the stream bottom. And so then that, bumps up the productivity of the stream bottom. So things like aquatic insects can then eat that, and make a living off of that. And then as the aquatic insect community, grows, that's more for the small fishes. And then the small fishes can feed the big fishes and so on. It becomes, a chain, that is connected. So they're help they're helping connect that overall chain and making the river bottom more productive. And that in turn, feeds the productivity of the overall system. When you think of rivers, especially the shallow ones, like the upper part of the Potomac above DC, the wadable parts, sunlight gets to the bottom, right? You can see the bottom of the river.
Hmm.
And so there's attached algae and plants and other and a lot of stuff living in the river bottom. But it's like, that river bottom is where all the action is at. Okay. It's where all the, productivity is at. It's feeding the system. So when you think about, how do the fish, they're in a system, what are they feeding on? Where is that food ultimately being produced from? Right. Well, it's from the river bottom. And so like you think about a landscape, and you think about the soil and, the plants that grow on the landscape, and then all the different birds, the mammals, everything that feeds off of the vegetation on a landscape. Well, it's kind of akin to that, right? It's like that river bottom is very productive, and it's super important for the overall, ecosystem in terms of the animals that are living there.
Hmm. Wow. God, that's cool. Yeah. I guess I always thought that the productivity would be like at the top of the river because I'm assuming that's where a lot of the like phytoplankton would be.
Well,
But
when you go down, like rivers are very dynamic, they're very complex, right? So when you go down into say the tidal fresh part of the Potomac, that's more a little bit like a big lake in a way, right? So you
hmm.
get really excess that those are really good dynamics for phytoplankton. So then you get freshwater phytoplankton that will bloom in those areas, and then that becomes a very productive area. But on the upper parts of the rivers, the upper more montane upland parts of the rivers that are shallow, in the low summer conditions, you might get, areas where you're getting a little bit of a phytoplankton bloom, but a lot of it's, fine particulate organic matter that's coming off of the landscape that's working its way through the river system. It's really feeding a lot of the overall, system in terms of
Hmm.
the mussels and the aquatic insects and everything.
Oh, okay. So I guess then maybe my question would be if the mussels are doing this type of like particle sorting, what have been some of the challenges to like freshwater mussels in um, surviving in the current like river systems? What have been kind of one of the major challenges for mussels in modern day?
Yeah, I mean, that's a great question. It's a super important question. And, we're always asking, we should all be asking, how do we, what's affecting mussels? We know that, in many places that they're declining and we've lost species, but, you think about rivers and the way they work, they're kind of like conveyor belts, right? They're bringing, waters, flowing up through the groundwater, but then there's rain and there's surface water. And as, we get big rainfalls, it's bringing particles and material off of the surface of the landscape, and in doing that is transporting say excess sediment at times, which can be potentially smothering to mussel populations, and it can also be transporting contaminants. So these small little particles that I talked about, attached to them could be high level of nutrients, okay, phosphorus and nitrogen, and that can maybe elevate the productivity of rivers beyond the level that you want. Okay, so that could potentially be a problem. They can also serve as a transport, for certain contaminants. So things like trace metals, copper, zinc, aluminum, these different metals that when they bioaccumulate in the tissues of freshwater organisms, particularly freshwater mussels, they can be problematic. At low levels, they might not be a problem, but as they accumulate and get at higher levels, then they start to affect the physiology of the animal. So it begins to affect, their capacity to filter, their ability to eat, just to osmoregulate, all the things that they do their overall physiology can be affected by certain contaminants.
Are those, I mean, like particularly the contaminants and the trace metals, are those things that the mussels are secreting out, or those are things that are still over time just like building up and up within the
I mean,
mussel?
it depends on, the specific, contaminant, but a lot of them can, accumulate in the tissues of the animals. Okay. So, they might be absorbed, they might be attached, we call it, say, absorbed to a small particle that they like to eat, right? And that's one thing they can't tell that it's laden a little bit with a particular contaminant. They can't sort at that level. They can't detect at that level. So they'll ingest, like a small particle that they would normally eat. So that's something that they can't discern, right? They don't have the ability to do that.
Mm, okay. And then, of course, that stays in the mussel. Then whatever eats the mussel builds, and those trace metals just keep going up and up and up. Yeah.
Mhm.
It's is there kind of a balance between this mussel serving as these great filters and being great e ecosystem benefit providers? Is there a limit to how much sediment or how much nutrient that we can kind of pump into the system before that filtering process kind of crashes?
Oh yeah, I mean definitely. We know rivers, for example, where there's very excess. Say banks are actively eroding and bringing in a lot of sediment to a system. That system will of course work its way through a river, begin to silt in certain areas, and then that becomes a problem for both the adults, but specifically you did a really good job explaining the life cycle of the mussels. So these very small larvae that we call glaucidia, they're attached onto fish hose, and these are larvae that are about a quarter of a millimeter in size. So 2 to 300 microns, very very small. So they metamorphose and they drop off into the river bottom. Well, when you're that small and you get smothered by sediment, you can't make adjustments. It's like you're just kind of smothered. And so what happens is that it affects what we call recruitment. The bringing in of the juveniles, the bringing in of the babies that you need to sustain a population over time. And if you stop that process for a lengthy amount of time, or it's just not enough,
Mm,
recruitment over time, then the populations begin to decline. The adults might be able to work their way around some of the heavy sedimentation, not always, but they can. They can do a better job of that. But the juveniles have a much harder time. So,
mm.
and that's the same is true with the contaminants. If the sediments are more contaminated, the juveniles are much less. They're not nearly as tolerant to that environment as the adults.
Is this, I mean, like this might be a simplification, but is in terms of like river water quality and mussels, is it a question of just numbers and like the more freshwater mussels are in the river, the better it can support and improve the rivers, or is it more of like we also need to address both the sediment and
Well,
the toxic
it's
metals issue?
it's a complex question because there's a history that needs to be understood. So, for example, one river might have had some some things on it that caused mussels to decline. Okay,
Hmm.
and that could have happened 20, 30 or more years ago, and we lost the mussel populations from that river. Okay, or they're at very low levels. Okay, but now, those problems have been cleaned up and they've been fixed, say 10, 15, 20 years ago. So the water quality could be good. Okay. And the stream bottom could also be healthy. It could be, or, it could be good. It could be decent. Mussels could, then survive there. Right. But now the native populations are gone, and there could be barriers in the way from keeping fish hosts from coming up into the areas where the mussel populations were lost. And so in cases like that, the environment could be good, even the fish hosts could potentially be there, but we need to put the mussels back, and that's
Hmm.
where restoration comes in. Okay, so there's rivers where they have a lot of potential for restoration. Okay, so where we could put mussels back and make a difference by having healthy mussel populations there. But in cases like that, a river will need our help in doing that. The mussel populations will need our help. There's other river systems where mussel populations are generally doing okay. In the Potomac, the greater Potomac, not all the tributaries, but large sections of the Potomac kind of fits that bill, where we have respectable mussel populations, but there's room for bumping the numbers up. And as we bump the numbers up, we can get more of the benefits that we talked about earlier. So I would say each case, each river, each maybe even part of a river, is a little bit different. You kind of need to understand like the nuanced differences of what's going on in a particular river section, what it needs to be, for the mussel population, say, to do better, to thrive.
Mm. I think I'm quickly learning that there is no like easy fit answer for freshwater mussels or for river systems overall. Yeah. Hmm.
Right. Mm-hmm.
Yeah. Well, maybe that's great transition then to kind of like the project that we're really both involved in, which is both like mussel restoration and mussel propagation. And I wonder if you could talk about just kind of what the state of freshwater mussel propagation is right now. I get the sense that we're still somewhat like early generally as compared to like oyster propagation and restoration. And I'm wondering if you can speak to maybe what are some of the outlying challenges or mysteries that we're still dealing with.
Right. Yeah. So I started doing muscle work, over 30 years ago, and so and I started out doing muscle propagation. So I've seen it the field, come a long way. When we first started doing this, there was only one facility really, doing, large scale muscle propagation. That was here at Virginia Tech.
Hmm.
This is the kind of first lab that was beginning to scale things up. And now, there's, almost every state, has a muscle facility or two. Like here in Virginia, we have three. And so, it's really grown a lot. And so that scale in terms of the number of facilities out there is super important, for really making a dent in, mussel population restoration and recovery of, say, endangered species. And so it's really advanced a lot. And then the specific technology that the facilities are using. I look at each lab, each mussel hatchery is like its own little experiment, if you will. They're all kind of thinking and they're all figuring things out. They're all coming up with ideas, and one lab will come up with a breakthrough like, oh, this is really working great for us, and then our community is really good at sharing stuff. So then they'll say, hey, we're doing this, we're getting great results. Then other labs will start doing that, and then so the knowledge sharing is at a high level. It really spreads around pretty quickly.
Hmm.
So that's good, and everyone's doing a little bit different things, trying to figure stuff out. But I still think it's a matter of scale. If you were to compare that to say the oyster world, it's a little bit different because the focus for freshwater mussel work is mainly two things: restoration of populations and the recovery of endangered species, right? So restoration might involve, large scale propagation, putting out mussels, kind of, like the 50 million mussel project. And, we're really, focusing on the ecosystem services and trying to make, say, the greater Potomac, a cleaner, better place, right? That's the focus. Another big focus, and this is the focus that I had spent, a big part of my career on, was the endangered mussels. There's a lot of
Hmm.
endangered mussels. So figuring out, how to propagate them, their life history, and then, growing them in a lab and stocking them and building their populations up to make them less endangered, right? In the oyster world, the focus is commercial, right? And so there's a financial incentive, like the growers, throughout the Potomac River Basin, they've also been very innovative. They've worked with universities, like, William and Mary, University of, Maryland, and so they've done a lot of innovation. And like I said, with the mussel labs, each of the growers, they have their own insights. They're making breakthroughs and figuring out how to improve the process, and they share that information. So, but the scale is a lot different, right? There's just a lot more, financial incentive, a lot more money involved, in the oyster business, right? And it's a
Hmm.
global thing. I mean, oysters being grown all around the world, for commercial purposes. And so there is some restoration. In fact, there's a decent amount of oyster, growing for oyster restoration purposes, but a lot of it is focused on, making oysters available for consumption, for, selling in seafood restaurants and stuff, which is an awesome and a great thing. A lot of people like oysters. But so I'm just putting a little perspective on the motivations, for the different fields, if you will.
Sure. Is there is there a potential for there to be like a freshwater mussel economy to like build up, whether for like restaurants or for anything like that, or are we?
So that, people have asked me that, over the years, and they're not like oysters in terms of being edible, right? I mean, you could eat them, right? But they're in rivers. They might have, higher levels of contaminants. And so the interesting thing about freshwater mussels is that they're burrowers, right? So they use their
Hmm.
foot to burrow down into the stream bottom, into the substrate. So their foot is very tough because of that. So an oyster, or a blue mussel, they attach to rocks, right? So they're living attached to a rock the whole time, and filtering the suspended material, like in the bay. And so their foot is very soft. It's not being used to burrow or anything. And
Hmm.
so the meat is much more tender relative to a freshwater mussel. So it's way more edible. So
Hmm. Okay, well then I will not be trying freshwater mussel anytime soon.
yeah,
I'll leave it for one more question, then we'll start kind of going into the audience Q&As. But just I'm just curious to hear what kind of your hope is for either freshwater mussels in the Potomac or freshwater mussels much more broadly than our own river system. What your hope is in the next 10 to 20 years for both
well,
in-stream
kind of
population or for research.
jumping off with what I was just talking about, what I see as super interesting, trying to think of some other, say awesome about the 50 million mussel project is that it's unique, and you might not realize, the uniqueness of the project because it's a partnership, right, between universities. So you got Virginia Tech, other universities, and you've got U.S. Fish and Wildlife Service, with say Harrison, Lake National Fish Hatchery. You got Maryland DNR and their hatchery. You got VDWR, and then you got private partnerships, and then you got NGOs like Potomac Riverkeepers Network. And then you guys are you know motivated and have this vision of getting the docks and getting the grow out, and framing what can be done for the Potomac River. And so that's a very unique situation. In fact, I don't think there's another situation like that in the United States, where you have this unique partnership, all coming together to bring resources together, but then to do grow out and then ultimately stock these mussels out
Hmm.
there to improve, the populations, but for restoration purposes. So I think partnerships like this truly are could be a model for the future, because it begin to leverage more overall resources, expertise, say at universities and federal and state labs, but also financial resources. The resources that you have there at National Harbor, with the pier and the dock, and then just the visibility that brings to the public to make them aware of what's going on. So there's a lot of really great things, to me, with this 50 million, mussel project in terms of the restoration, but also educating the public, and then just bringing together all these unique entities to pull this off. And so I see that as hopefully a model for the future.
I couldn't have said it better myself. Thanks, Eric Jones. That's great.
Yeah,
Great. So I'm just gonna kind of rapid fire some audience Q&As, yeah, if that works for you.
sure.
So in general, or particularly in the Potomac, what predators feed on freshwater mussels?
So, the Potomac depends on where you're at in the Potomac, but there's fish, there's certain catfishes and sturgeon, and that will eat freshwater mussels. Okay, so they go around mucking around in the bottom, looking for them, and they can eat them. Okay, and then there's otters that are making their way back, into the system, and then there's muskrats, raccoons,
Mm,
So there's a range of animals that can, feed on freshwater mussels at some level. So
nice. Um, this is one that, particularly with our conversation with contaminants, that I sometimes worry about as well. The question is if the contaminants are working their way through the food web, and the apex predators consume these and die. And I guess this applies for freshwater mussels as well. Wouldn't those contaminants then re-enter the ecosystem in some way?
they do. I mean, but they can. Some contaminants, though, can get processed, right? They can kind of, be moved through the system and get processed. So there's biological and physical processes that can, ameliorate or kind of tamp down the amount of contaminants out there. And that's the unique thing about rivers is that, they're like these conveyor belts. So they're super dynamic, and if a contaminant's out there, it's ultimately going to be working its way down through the system, then ultimately out into the ocean. So
Hmm.
they can stay in and persist, in riverine environments for a long time, but they are getting worked. They're getting reworked and they're getting processed. So just because a contaminant's out there, one level back in the say 50s and 60s, it doesn't mean it's going to stay like that, forever and ever. They do eventually work their way through, and it really depends on the kind of contaminant, whether it's a trace metal or something that's organic in nature. There's different kinds of organic contaminants that can be more persistent or even less persistent, depending on how they can get processed.
Hmm. And maybe with that, just I know the map that I showed about Quinter shows that uh, there at least Potomac population kind of like peters out when you get more into brackish water. Um, is that is that true for mussels generally when we get into more brackish water, or is it more of like a species change at that point?
Generally, that's true. So
Okay.
as the salinity increases, so if you look at the Potomac, for example, the lower part of the Potomac, below DC, around the airport, all the way down to maybe above the 301 bridge is tidal fresh, and the mussels do pretty good there. So they're out there, but then you get below the 301 bridge, and then the salinity starts to pick up a little bit. And once you start getting above, say 2, 3, 4, 5 parts per thousand, mussels are going to start to drop off. So for example, the brackish parts of the Chesapeake Bay might range from depending on how much water is coming into the system between 5 up to maybe 15, 20 parts per thousand. Full strength seawater is 35 parts per thousand, right? So but once you start getting up to 1, 2, 3 parts per thousand, mussels probably are going to start to tailor off. They can handle pulses of saline water for a bit. They're not going to die immediately, but being constantly exposed to them, they can't handle that. They just can't effectively osmoregulate in those kind of conditions. They can't maintain their internal balances like they need to.
Got it. Um, Speaking more to your kind of work with reintroducing both native or endangered species, um, is there any type of competition when we put them back into the river? Is there any competition with invasive species? And kind of what is the issue, maybe the challenges or the issues when placing native mussels back in with invasive species?
You mean specifically like invasive bivalves, or just yeah?
Invasive bivalves, yeah.
Yeah, so we do have introduced kind of invasive bivalve. It's through almost every river system and lake system throughout the United States. It's the Asian clam, so it's the round. It's very round, maybe the size of like almost like a quarter or something. You'll see them out there. They're kind of yellowish in color. Sometimes they can be a little bit brown, but they're very round looking. And so those clams, the Asian clam, is out there by the millions and if not billions in most of these river systems. And so they can get at high enough densities probably compete with freshwater mussels. But they certainly coexist. That's for sure. So like as long as the densities of the Asian clams don't get too high, they're probably not problematic. But if they reach real high densities, The Asian clams tend to like really sandy environments, and they can get real high densities in sandy environments.
Hmm.
But the mussels like more of a mix of sand and like, pea gravel, kind of cobble type material. They do best in something like that. So they probably do compete, a bit with, Asian clams, but it's probably not problematic until they get to super high densities.
Got it. Okay. And then for these, I'm gonna group these kind of like last three questions into one general theme of mainly like how can people help, really. We've got a question about what are some leading kind of organizations or agencies that people can follow? What's the role of K through 12 or college groups that can get involved? And then just generally, what can the public and like non-technical
I mean,
experts do?
what I encourage people to do is, we care about the things that we see and we know and that we love, right? And so, like, if you can, see something in action firsthand, right? If you grow up fishing or, being out on the river, spend time out there, enjoy it, right? Get out there and, maybe, put on a mask and snorkel, start looking around, see if you can find some, right? You want to do it safely and get in the shallow areas and, do it with a team of folks, but, try to experience rivers and see what's really sitting in the bottom of these rivers. Okay. And as you learn a little bit more, be a spokesman for them, be an advocate, be a spokesman, be willing to talk about them and share your experiences with other people so they're aware. Like I said, when I was growing up, I didn't know about these guys. I didn't know about them. And there's a lot of people that grow up right next to a river. I mean, I can't tell you how many people I've talked to over the years that literally grew up right on a river and they don't even know that the mussels are out there. And so it's like, that's, you know, helping in that regard in terms of talking about them and educating. That in many ways, that can be one of the biggest things because once you know that things are there and you understand how diverse and all this incredible stuff that's in a river, then you begin to care and then you want to do something about it. So for me, the first step is, making that connection and caring. There's lots of ways that people can do that, in terms of being willing to get out on the river and see it, firsthand. I've spent a lot of time on the Potomac system, and we all have this idea that this is super. It's one of the more urban areas throughout the country. But there's when you're out on the Potomac, there's a lot of cool stuff out there. You see bald eagles and ospreys, and there's lots of fish, and the fishing can be good. And when you see that, that is there, it makes you begin to care about it. You want to take care of it. So and I think doing that is a big step in the right direction. And then there's lots of groups out there that can use help. There's your group. There's the Nature Conservancy. There's different river groups. American Rivers. There's lots of groups out there that can use help. So there's lots of ways to get involved. So
Yeah, we have a world of beauty and complexity right below the water surface. We should all get there out there and view it. And perfect timing. One of the ways you can do that, we've got a Shenandoah snorkeling trip that everyone should come to.
yeah, there you go. Exactly. I definitely encourage any of the listeners to try and get out and do that. It's eye opening. It's like I've been snorkeling rivers for more than 30 years. And I never get tired of it. I love it. It's like I'm out with my students and technicians, and sometimes just I'll go down the new river here that's near Blacksburg and just snorkel around. It's a great way to cool off and see some interesting stuff. So
Well, my partner doesn't know it yet, but I think I know what we're doing this weekend. So thanks for the thanks for the inspiration. Um, yeah, again, thank you so much for your time today. For anyone that's still watching, if you're interested to learn more about the 50 Million Muscle Program or interested in volunteering, please feel free to send me an email. My email is evan@prknetwork.org. Please feel free to come and see the muscle program as well at National Harbor, particularly any Wednesday or Thursday during the summer. We will always be there. Um, but with that, Dr. Jones, thank you again so much. We really appreciate your time.
yeah, you bet. I enjoyed it. Thanks for the invitation.
Sure, of course. Um, and with that, thank you all for joining. And we wish you all the wonderful rest of the week. Thanks, everybody.
All right, see you later.
Okay. Thanks, everyone.